Hi guys, it's me again, Odanga Vincent. The channel is called Odavig Structure Hub. This is a place where you learn, build, and innovate. Today I want to tackle example number 2, and that is stability of a dam. The question is on the board, and it reads, a trapezoidal masonry dam having top width 1 meter and a height 8 meters is retaining water up to a height of 7.5 meters. The water face of the dam is vertical. The density of the masonry is 2240 kilogram per meter cubic, and the coefficient of friction between the dam and the soil is 0.6. Find the minimum bottom width of the dam required. So that is the question, and this is the dam. This is the dam. So in your exam, you will be required to draw this dam, because you may be provided just a dam but not the forces as I have drawn here. So you will draw the dam and the water being retained and indicate the forces. You have force F, and you have W, which is the weight of the dam, and this F and W produces a resultant R, which cuts the base at M. And then the weight of the dam, which is W, it cuts through the COG of this dam at point N. So at point N is the COG of the dam. And then this is point A, this is point B. As we have been told, the top width is 1 meter and the bottom width you have not been given. So the height of the dam is 8 meters, which is capital H, and the height of the water is 7.5 meters. And this water, it exerts pressure at this point, which is F, and it is at H over 3 from the base of the dam. H here is the small h, which is 7.5 over 3 from the base of the dam. So this distance is x, which is distance nm, and distance d is distance am. So what you are supposed to do is to calculate the minimum bottom width of the dam. So we are supposed to calculate this b. So let's see how we can calculate the minimum bottom width of the dam. So let B be the width of the dam at the base. So this is it. Let B equals to the width of the dam at the base. And then we will consider 1 meter length of the dam, like that. Then after there, we will start calculating the force F. So you know that F is equal to unit weight of water times area times H bar. So whereby the unit weight of water, we know that the density of water is 1,000 kilogram per meter cubic. So we will multiply by 9.81. That is to say, we are changing from kilogram per meter cubic to Newton per meter cubic times area. The area of this dam, the H is 7.5 times 1 meter length we have considered, then times H bar is 7.5 over 2. Then you punch your calculator to obtain the answer. So the answer is 275,906.25 Newton. Remember, it is acting at h over 3, which is 7.5 over 3 from the base, like that. Then we continue. So allow me to erase here to create a more space for more calculation. So we now proceed to W, which is the weight of the dam. So W is equal to the weight, unit weight of the dam times area of the dam, then times length, like that. So the unit weight of the dam, we have been told the density of the masonry is 2240. So we have 2240. So that is kilogram per meter cubic. Again, we will convert it to Newton per meter cubic by multiplying the gravitational acceleration, which is 9.81, then times area. Area of this dam is a half AB times H. So it is a half A is 1 meter, plus B you have not been given, times B, then times H is 8, then times 1 meter length of the dam, like that. So we'll end up having, we'll simplify the expression. So 2 is 1, 2 is 4. So let's punch our calculator. So the answer is 897 into bracket 1 plus B Newton. So this is our weight of the dam, which is capital W. And remember, this W is acting through the center of gravity of this retained, of this dam. So the center of gravity, we are supposed to calculate this distance AN. So AN is given by this expression. So AN is given by A square plus AB plus B square over 3 into bracket A plus B, like that. So our A is the top width, which is 1. So 1 square plus 1 times B, you have not been given B, times B plus B square, you have not been given, over 3 into bracket A is 1 plus B. So let's simplify this. So 1 square is 1 plus 1 times B is B plus B square over 3 plus 3B. So this is a N, like that. Now after getting this AN, the next thing to do is to calculate distance X. So X is given by, so X is equal to F all over W times H over 3. So this one is equal to, so let me do it here. So x is equal to f. F is the force we calculated earlier, which was 27,906.25 over our W is this one, 87,897.6 into bracket 1 plus B, then times H over 3, small h, which is 7.5 over 3. So if we simplify further, we'll end up having 7.847 over 1 plus B. So this is distance x, which is distance nm, like that. So the next thing to do is to determine our distance d. So d is equal to, as you can see, d is from here to here, so it will be a n plus nm, which is distance x, like that. So an is this distance, So allow me to clean here. So this an is this distance 1. So we are looking for d. So it's 1 plus b square over 3 plus 3b, then plus nm, which is x, that is 7.847 over 1 plus b. So that is our distance d. So let's proceed. So remember the stability of a dam. So the stability of a dam in tension, we said that if d is less or equal to 2 over 3 b, then no tension, like that. So we are going to relate. So let's say d is equal to 2 over 3 b. So we remove this sign and we replace it by equal sign. So we are going to relate, because we have d and d, so we are going to relate this 2 over 3b to this and get an expression that will give us the value of b. So we will have 2 over 3b is equal to this expression, 1 plus b square over 3 plus 3b plus 7.847 over 1 plus b. So let us simplify this. So let's get the LCM of this expression. So it's equal to the LCM of 3 plus 3b and 1 plus b is 3 plus 3b. Then 3 will go into 3 plus b, 1 1 times this expression, it will be 1 plus b square. And then this will go into 3 plus b. So we have 3 plus 3b. Then you divide 1 plus b. So it means 3 into bracket 1 plus b over 1 plus b. So here 1, here 1. So it will go into this one 3 times. And then you multiply 3 by 7.847. So plus 3 times this is 23.541, like that. So it means 2 over 3b is equal to this. Now let's cross multiply. So 2 over 3b is equal to 1 plus b. So 1, let's put the like term together. So we will have 1 plus 23.541, which will be 24. This is 24.541 plus b square over 3 plus 3b. And then we cross multiply like that. So we'll end up having we'll end up having 2b multiplied by 3 plus 3b is equal to 3 multiplied by 24.541 plus b square, like that. So let's open the bracket. 2b times 3, that is 6b. 6b plus 2 times 3, 6b square is equal to 24.51 times 3. Let me do it here. 24.541 times 3. The answer is 73.623. And then 3 times b, that is 3b plus 3b square. So we put like term together. We'll end up having 6b square minus 3b square plus 6b minus 3b is equal to 73.623. So if we continue, we'll end up having 3b square plus 3b is equal to, let's bring this to the other side, so it will be minus 73.623 is equal to 0. So this is a quadratic equation. Then you can use your calculator to solve the quadratic equation. So if you carry out the operation using your calculator, a scientific calculator, you will end up having b is equal to 4.48 meters, or b is equal to negative 5.48 meters. So ignore this one. So therefore, b is equal to 4.48 meters. like that. So if you don't have a calculator that can solve a quadratic equation, then you can use the quadratic formula or any other method to solve such a question. So let's proceed. Allow me to erase here. Again, let's consider for sliding. Let's check for sliding. So sliding, we know that there will be no sliding if mu times W is greater than F. The mu is the coefficient of the soil and W is the weight of the dam and F is the force F. So we know that the mu is 0.6 from the question, and the weight we calculated earlier was times 896.6, then B plus 1. Should be greater than F. Our F was 275,906.25. So it means if we divide this 0.6 times 896.6 on both sides, we'll end up having 0.6 times 896.6 B plus 1, then you divide by 0.6 times 896.6, so it should be greater than 275,906.25. Again, you divide by 0.6 times 878.96.6. So it means here 1, here 1. So B plus 1 is greater than, you can punch your calculator. So if you punch your calculator, you will end up having 5.23. So it means B is greater than 5.21 minus 1. So this one will cross. So it will change from positive to negative. So it means B is greater than 4.21 meters. So we have obtained B as 4.21, and also, no, B is greater than 4.21. So it means B should be greater than 4.21. So therefore, our B is 4.48 meters. So in short, I will say that hence the minimum bottom width of the dam, so that there is no tension at the base of the dam, and also there is no sliding of the dam, should be greater of the two values given by the equation. So this is the first one and this is the second one. So the minimum bottom, so therefore, the minimum bottom width is equal to 4.48 meters, and the question ends there. I want to encourage those who have not subscribed to this channel, please subscribe and hit the notification bell so that you may be the first person to be notified when I upload a video. So in my next session, I will be winding up the stability of a dam so that I can start retaining walls. So stay tuned, share this video, comment and like. Thank you for your time. We meet again in my next session.